Hello everyone, welcome back to your channel Physics with Oliver. Today we will discuss the important concept which is associated with electrostatic potential. Okay, so let's start. See, suppose it's a sphere of radius capital R, Q charge is present. Okay, you have to calculate, this is a conducting sphere, you have to calculate the electrostatic potential inside the sphere, outside the sphere and on the surface. Okay, suppose it is asked that you have to calculate the electrostatic potential at the point P1 and electrostatic potential at the point P2 and electrostatic potential at the point P3. Okay, the distance of P1 from the center is R1, the distance from P2 from the center is P3 is R3, and distance from P2 from the center is capital R, which is the radius of the sphere, right? So for the inside point, which is the inside point, P1 is the inside point. For the inside point, the potential at the point P1 is 1 by 4 pi epsilon naught q divided by capital R. This is the potential inside the sphere. You can see here small r1 term is not present here. That means upon the distance of the point P1, the potential is independent of the distance of the point P1. That means inside the sphere the potential is constant. So from here we can conclude inside any point of the sphere, the potential is constant. Okay, because capital R is the radius of the sphere, which is constant. Now we will come outside point. Which one is the outside point? P3 is the outside point, right? P3. So potential at P3 is equals to 1 by 4 pi epsilon naught q divided by R3. It depends on the distance. Okay. And now one point is left, which is on the surface. Potential at P2 point, right? Potential at P2 point on the surface. On the surface, the potential is 1 by 4 pi epsilon naught q divided by capital R. So from here we can say that the potential on the surface and any inside point are same. Using these three equations, we will discuss another important concept. If you have not subscribed yet, please subscribe the channel and press the bell icon. We will continue this video. Now we have drawn three concentric spheres. Okay, first sphere, the innermost sphere has radius r1, the second one radius r2, and for the third one the radius is r3. On the surface of the first one the charge is q1, on the surface of the second one the charge is q2, and on the surface of the third one the charge is q3, right? Now we have to calculate. Suppose this is sphere A, this is sphere B, and this is sphere C. Now we have to calculate the potential on the surface A, the potential on the surface B, the potential on the surface C. Okay, we have to calculate these three terms. When we are calculating the potential on the surface A, we have to consider three spheres. Okay. Now suppose we are considering this point. This point, suppose point number 1. This point is the surface point for the sphere A, right? For the sphere A, this is the surface point. For the sphere B, this point is the inside point. For sphere C, this point also is the inside point, right? Here we have already discussed the potential for the inside point, outside point and the surface point, right? So at first we will consider the term which came from the sphere A. For sphere A, it is a surface term. So 1 by 4 pi epsilon naught. For sphere A, it is Q1 by R1, surface term. For sphere B, it is inside point, right? So Q2 divided by the radius of the sphere B, R2. For the sphere C, this is also inside point, Q3 divided by the radius of the sphere C. Okay. Now we will consider the potential at the point here, point 2. At first we will consider the influence of sphere A, then sphere B, then sphere C. For sphere A, this is the outside point. For sphere B, this is on the surface. And for sphere C, this is the inside point, right? That means for sphere A, it is the outside point. So we will write Q1 divided by the distance of the point from the center, that is R2. This is for A. And for B sphere, this is the surface point, so Q2 divided by R2. And for C sphere, this is the inside point, so Q3 divided by the R3. Okay. Now come to this point, the point 3. This point is the surface point for C and outside point for A and B, right? So for outside point, this is Q1 divided by the distance of the point 3 from the center, that is R3, and Q2 divided by the distance of the point 3 from the center of the sphere, this is also R3. And for C, this is the surface point, so Q3 divided by R3. Is that clear to everyone? This first term is the contribution of sphere A, the second term is the contribution of sphere B, and the third term is contribution of sphere C. It is the surface term, it is the inside term, it is also the inside term. This is the contribution of A, and this is the outside point. This is the contribution of B, this is the surface point, and this is the contribution of C, this is inside point. This is the contribution of A, that is outside point. This is the contribution of B, that is outside point. This is the contribution of C, that is the surface point. I think this is clear to you everyone. We will discuss problems on this concept. Please subscribe the channel and press the bell icon and share with your friends. Thank you everyone.